So the question says find the inverse of f of x equals x squared. So we go through our 4 steps, and the first step says replace f of x with y, and then we're going to interchange x and y, so in that case we get x equals y squared, and now we're going to solve for y, so that y equals, the opposite of squared is the square root of x, and when you square root something like this with a variable you need plus and minus. So the final step is replace this inverse notation, f negative 1 of x equals plus or minus root x. Okay, which looks a bit complicated. So if we go back and graph our original function x squared, we know it goes through 0, 0, 1, 1, 2, 4, and 3, 9. I think we've got 9 here. There's 3, 9. And it mirrors the other side too. So we've got that, and negative 3, 9 there. So this function looks like this. See if I can draw a nice little curve. And goes up like that. Well, we know the function and its inverse are reflections in the line y equals x. And y equals x comes down, goes through 0, 0, 1, 1, and charts this path along here. Do it as a dotted line, and it goes all the way down here, going through all the points that have the x and the y value equal. So that is the line y equals x. When we come to trace the inverse function, all the points get reversed. So where we had the point on f of x of negative 2, 4, we'll do the first 5, negative 1, 1, 0, 0, 1, 1, and 2, 4. So all these points should be familiar for us. For the inverse function, all those points get reversed. So the point negative 2, 4 becomes 4, negative 2. 1, negative 1, 1 becomes 1, negative 1. 0, 0 stays the same. And of course we get 1, 1, and 4, 2. So they are the 5 points we're going to plot here. So 4, negative 2 is down here. 1, negative 1 is there. 0, 0 is the same place. 1, 1 is the same place. And 4, 2 is there. And of course if you did other numbers you get 9, negative 3, etc. And this graph looks like this. Same curve. And that is the mirror image of y equals x in the line, the mirror image of f of x equals x squared is the red line, and the image in the line y equals x is the blue line, plus or minus root x. So what does the plus or minus mean now? Well, the plus or minus has 2 parts to it. The plus root x will be the top of this graph. And so I can just do it in a bit of a thicker line to make it clear. So plus positive root x will be this bit here, the top bit. And the negative root x will be the bottom bit here. Okay, so this graph, this blue line is made up of 2 points. The top bit, y equals root x. And that will be the bit at the top here, y equals root x. And the bottom of this graph will be y equals negative root x. Okay, and that becomes quite important later on. But what you notice about this blue function, this y equals plus or minus root x, it's not a function at all. If we take a vertical line, there's a spare vertical line I found lying on the side of my page, and pass it over this function, the blue function, you can see there's 2 intersections everywhere. Therefore it's not a function. Compare that to the red line, which we know is a function, y equals x squared. A vertical line intersects the red line once everywhere. So therefore it is a function. For the blue line we can see 2 intersections. Therefore it is not a function. And that's a problem. So if we now look to find the inverse of f of x equals x squared for x greater than or equal to 0, mathematicians now have created a way of finding a solution. So if we just take the values greater than 0, i.e. x equals 0, greater than or equals 0, so 0, we've got 0 is 1, 1, 1, 2, 4, and 3, 9 up there. That will be half the parabola we drew before. It's still a function, still passes the vertical line test. If we now go through and follow the lines, the rules for finding the inverse, we replace f of x with y, interchange x and y, and now solve for y, we get y equals root x. So the inverse function here is not plus or minus anymore, it is just positive root x. Because when we go to draw the inverse of this function as a reflection in the line y equals x, we will indeed get the red line. There's the line y equals x coming through here, and now the blue line is a reflection, the red line is a reflection of the blue line in the line y equals x. So this is f of x equals x squared, and this one is the inverse, f negative 1 of x equals positive root x. And in the same token, if we wanted to find the inverse of f of x when x is less than 0, we'd get that graph. And if we took the reflection of that one, we would end up with the bottom half of this parabola there. So this would be f of x equals negative root x. Now the book goes into this in some detail, but it's not essential to know this. This is just extra work. One of the questions the book will ask you to do is find the inverse of a function that is quadratic. So f of x equals x minus 2 squared plus 1. So we follow the same rules, we replace f of x with y, and we get x minus 2 squared plus 1. Subtract the 1, because we're going to, interchange x and y now. So we get x equals y minus 2 squared plus 1. Got to solve for y there. So we subtract 1, we get x minus 1 equals y minus 2 squared. And we're going to square root both sides. So we get the square root of x minus 1 equals y minus 2. But we've got to make it plus or minus because we've not designated any restrictions on the function yet. Take the 2 over, and I'm just going to switch it around. And we get the function 2 plus or minus root x minus 1. There. If we come to graph this out, the original function here has got vertex 2, 1, and the graph goes upwards. So let's just put the calibrations in. And 2, 1 is there. And we know that this parabola goes up, and we'll just do it any parabola like that. Comme ça. The line y equals x will come right down the middle here like this. So we know that the blue line will be a reflection in the line y equals x. Well, the vertex of the original was 2, 1. The vertex of this one, because it's still going to be a parabola, is going to be the other way around, 1, 2, which is up there. We know that this parabola is going to go to the right. There's going to be an intersection on the line y equals x for both lines, so it's going to come like this and like this. And that is the blue line and the green line are reflections in the line y equals x down here. So the book then asks you to look at functions like this. F of x equals 3x squared minus 6x plus 1, and it asks you to find the inverse. So first of all, we know this is a parabola, so we can do it by partial factorization. We know that f of x equals, factor out 3x, and we get x minus 2 plus 1. So therefore we've got x equals 0 there and x equals 2 there. So the vertex will have an x value of 1. If we substitute back in, f of 1 equals 3 times 1 squared minus 6 times 1 plus 1. So that's negative 3 plus 1 is negative 2. So the vertex is 1 comma negative 2. So therefore the original function is f of x equals x minus 1 squared minus 2, because that would give me vertex 1, negative 2. What number goes in front here is quite interesting. It is simply the number at the top here in front. The original a value here will go right there. So therefore this value here is going to be 3. So now we can find the vertex of this, the inverse of this function. So we replace f of x with y, and we're off the same as we were before. So interchange x and y. And we're going to solve for y now. Take the 2 over, x plus 2 equals 3y minus 1 squared. Divide by 3. And now we can square root both sides. So y minus 1 equals plus or minus again, because it's taking the square root, x plus 2 over 3. And then y, or f negative 1 of x, equals 1 plus or minus, take the 1 over, root x plus 2 over 3. That's an x there.